parallelogram is that you need to know is that it's made of two sets of parallel lines. So if you're looking at any of these pictures, this, first off, these two little dashes next to each other is parallel. Math people are lazy and we also suck at spelling. So this means parallel. If you want to write the word parallel, put parallel. It's literally created by two sets of parallel lines. You have a parallel line set that runs side to side, and then you have a parallel line that makes the sides, and that's creating a parallelogram because it's parallel lines and it's a four-sided figure, okay? So there are two sets of parallel lines. Number two is going to actually help you solve equations. So the opposite sides are congruent. And same thing, I put an equal sign with a squiggle. That means congruent. They're equal. So that is something that will help you solve or set up an equation. Number three, opposite angles are congruent. So if I have a top left angle, or top left is over here, and then a bottom right angle, their opposites are going to be congruent to each other. So opposite angles, not the same side, opposite. So going across like disco. Okay. Number four is, this is the word that I suck at spelling, that I cannot spell for the life of me. I think I spelled it right this time. I had to look at a piece of paper. Diagonals. Is that how you spell diagonals? Whatever. Okay. The diagonals bisect, and it's not creating an angle bisector. The lengths are bisecting. So only the lengths are bisecting, meaning whenever the diagonals intersect with each other, the diagonals are cutting themselves in half. They're not creating angle bisectors in the corners. So there's no bisecting of angles. And then the last thing is that same side angles are supplementary. This is from the beginning, like 180. We had two words, 180 supplementary, and then 90 was complementary. So the same side angles, if they're on the same side of the parallelogram, they combine to make a total of 180. So we know four-sided shapes add to make 360 on the inside. So they add to make 360, but if you're only looking at half of the picture, half of the angles, then you would add to make 180 because it's literally like half of the parallelogram. So you can either look at the bottom half to add to make 180, you can look at the top half to add to make 180, you can look at the right side of the picture, the left side of the picture, half of it is making 180. So two angles are adding to make 180. So let's start with numero uno, okay? So we're going to, looking at all of this is kind of overwhelming. I wouldn't look at this. I would just fill in what I can on the picture and then go back and look at these later. So if I know that the top is 15, I know that the base is also going to be 15 because this part is congruent to this part. So I'm going to put a 15 down here. So I'm going to kind of just move around numbers in my picture, see what I have, and then see if I need anything else. I know that this side is 8. This side is congruent to this side. So if 8 is on the right, I can move 8 to the left because it's a length. The lengths are always on the outside. The insides are the angles. So I had 15 up top, so I put 15 at the bottom. I had 8 on the side, so I put 8 on the other side. And now I have a 68 that I can move somewhere. Which angle would be congruent to angle D? B, because opposite angles are congruent to each other. So B and D are congruent, so I can move 68 degrees up here. So those are all the numbers that were given. So let me see if I can fill in everything. If not, we'll go back and add some more. So I know A to D is going to be this length. So this is 8. I know D to C down at the bottom is 15. And notice that now we start using one letter and it says the measure of angle. So now we're talking about the inside of the picture. Do I know what A is? No, not right now. So let's go to the next one. Do I know what B is? Yes. So let's fill that in. 68 degrees. And then angle C, I don't know. So we have to go back and we're going to add in angle A and C. We could do this one of two ways. We can think about the whole inside needs to add to make 360. And we know these angles are congruent. Or we can use this fifth thing, which says same side angles are supplementary. So if I cover up half of this picture, so if I cover up, I don't know, the left side of it, this angle B and this angle C are supplementary. If I do the other side, this angle D and this angle A are supplementary. If I cover up the bottom or the top, this angle D and this angle C are supplementary. And then same thing, I could cover up the bottom and just look at the top. 68 and A are supplementary. No matter what, one side is going to be 180. So if I look at this, and you could write an equation, you don't have to write an equation. If I do 68 plus something, 68 plus, we'll call it C because I'm trying to find C, equals 180. You could do this in a calculator. You don't even need to write an equation. What would C have to be? 112, because you would minus 68 to both sides, and then you would get 112. So in a calculator, you could do this. You do not need to write an equation. You do not need to show work for this. I'm okay with you just using a calculator, okay? So 112 can go here, and then I also know opposite angles are congruent. So C is 112, A is also 112. So I'm going to fill those in over here and over here. And then I'm going to put the little degrees just because they're the angle measure. If you forget the degree, it's not a big deal, but I'm just going to put it in there. Okay, let's go to 3. We're going to use that same kind of process. Actually, disregard 3. Actually, no, do 3. I lied. Don't listen to me. Do 3. Fill in what you can. Add the number where you want. Yes, lengths only, not angles. Okay, so based on what I know, let's see what I can move around. So where else can I put 27? At the bottom. It's at the top, so now it's going to the bottom. The 18 is on the side, so I'm going to move it over here. I also have another number in the picture, which is 7. Where else can 7 go? VS. So 7 can go here because diagonals aren't creating angle bisectors, but they are creating equal pieces. So this piece is congruent to this piece. So it's splitting the diagonals into 2 equal parts. And then let's fill in what I can. So from U to T is going to be 27. S to T is going to be 18. VS is 7. And then it wants to know VT. Does anybody see a piece of information that I'm like missing? What'd you say? Beautiful. So this whole thing is 30. So not all the numbers are in the picture. I have to add that. RT is 30, which means that this piece is 15 and this piece is 15 because it's creating a bisector. The diagonals are bisecting. So this length is 15. Not too bad. Okay, so now we get into a little bit weird. These were all side lengths. Side lengths make sense. The angles are a little bit difficult. So number four, this has technically parallel lines cut by a transversal in the problem. So this is from stuff from quarter 2. I know that this is 21. That does not mean the angle below it is 21. It is not an angle bisector. Could it be? Yes. Is it ever going to be? Probably not. There's like a 1% chance it's going to be the same angle. Okay. So if this is 21, that is not 21. This is 71. This side is not 71. So I have a piece of information. It says the measure of FED, the whole angle F to E to D, this whole thing is 134 degrees. So how could I figure out what the little angle next to 71 is? I know this is 71. I know the whole thing is 134. What could I do to figure out that little angle? Not split it, not cut it in half, because it's not an angle bisector. The whole thing is 134. It's not obtuse angle. This little tiny angle next to it is 71. Subtract. Good. So if I take 71 away from 134, what does that mean this little tiny little baby angle is? 63. So this angle is 63 degrees. So I'm going to squeeze in a little 63 degrees. Okay. And I'll zoom in. The pictures, I know they kind of get a little small. Sorry. So that's 63. The whole thing's 134. Now this is where parallel lines cut by a transversal come into play. So if I'm looking at this, if you're using highlighters and you're trying to match me, don't do this on your picture. Okay. But this is creating parallel lines. I have 2 sets of parallel lines. It's being cut by a transversal. So that is my transversal. So we can actually use alternate interior angles to place 71 and 63 on the opposite angle. But it's not going to be 71 on the left side and 71 on the left side. Opposite interior angles means it jumps across the transversal. So 71 is on the left. Now it's going to be on the right. So I'm going to put 71 over here. 63 is on the right, so now it's going to end up on the left. So it's jumping across the transversal because it's parallel lines cut by a transversal, so it's the opposite of what you're thinking. 21, if you look, 21 is above it, so now it's going to be below it over here. So I'm going to put a little 21 over here. So based on the numbers that I have, let's try to fill in what we can. So I have DEC. A lot of people still to this day get confused with this. They are using 3 letters, but it only means angle E. Yes. So if I start at D, I go to E, and I end at C, what angle is that actually talking about? I'm not adding them all together. 63. Because it's talking about from D to E to C, so it's talking about this right side angle. The next one it wants is CDE. CDE, do I know that whole angle? Because it's talking about the whole thing. No, I don't know that whole thing. And it's not 42. I'm not doubling 21. So that's not, I don't know that yet. So let's skip that for now. ECD. ECD is what? 71. And then DFE. So D to F to E. So now I'm talking about this little angle over here. Do I know that? No. So this is where we can either add in total to make 360, or I can just look at half of my picture. So let's do half because it's easier and we have less math, okay? So once again, I can look at the bottom half, I can look at the left half, I can look at the right half, or I can look at the top half. It doesn't matter, okay? So let's do, let's just say I'm looking at the bottom. So if I'm looking at the bottom, I'm looking at all the angles that are in the bottom half of the picture. So I have a 21 that's over here. This angle right here, I'm going to say 21 plus, I don't know this angle. So I'm going to say X. I'm going to put a little X here. Boop, boop. X plus this angle right here. I can say 71 plus 63, or I could say 134 because the whole thing is 134. So I'll say plus 134 equals what? What is half of the picture going to equal to? 180. So you can do this in a calculator. You don't necessarily need to solve this equation. Some of you want to solve it though. I'm going to combine 21 and 134, and then I'm going to just subtract it to both sides. So what do we get? 25. So this angle is 25 degrees, which is the last one that I asked for. DFE is this small angle, so I'll say 25 degrees here. And then we'll go back and fill in this little missing one, CDE. So CDE is talking about this whole angle. I know that this was 21 because I crossed over the transversal. I know that this one's 25, so I'm going to put 25 here now. What would be that whole angle? What? 46 degrees. Let's go to the back. The back is easier than the front. Just putting that out there. That's like the hardest it's gonna get. Okay. Let's go to the back. Let's talk about. We're gonna set up problems because the problem is setting up the problem. It's not really solving it. You guys are pretty okay with solving the equations. Let's set up like 3 of them together. Okay. Thank you. Here's the paper that we're working on. There you go. Let's set up number 11. So 11, take a second, look at 11. We're only given 2 pieces of information, so we don't have diagonals, so it doesn't look super crazy. What do I know about this angle and this angle? They're congruent. They're equal to each other. So what kind of equation could I solve to solve for X? Equal them to each other because they're opposite angles. So the equation is 6x minus 15 equals 4x plus 11. So because they're opposite angles are congruent. You guys can solve that. Let's set up another equation. The hard part's setting up the equation. You guys are getting significantly better at solving the equations. Let's go to 12. 12 is very similar to 11, but the placement is different. Are these angles congruent to each other? No. One is obtuse, one is acute. They're not opposite of each other, but they are on the same side. So what do same side angles add to make? 180. You could technically put this angle down here and put this angle over here and then add them all to make 360, but that's just going to make your life even harder. So same side angles, because they both share the same side, they both share the left side. I'm going to say this angle plus this angle equals 180. So we'll put 3x plus 5 plus ax minus 12. And then we'll set up one more together. Take a second, look at number 9. And if you add the information to your picture, it will help you significantly. The picture is there to help you. So for number 9, put the information in the picture. Visually, it will help your eyeballs understand what is happening. I'll show you in a second. It's like, okay, so I know that whole thing is 74. I also know W to V is 4x plus 1. So there's two different ways that I can think of that you could do this. Does anybody know where else maybe I can put something? Where else could 4x plus 1 go? The other side, because it's a diagonal, so it's splitting. So 4x plus 1 can also go here. And now if I know the whole thing is 74, what could I do? Add them and equal it to 74 because it's a length. So you could do 2 times this equals 74, or you could literally add it twice, which I think is what most people are going to do, is say 4x plus 1 plus 4x plus 1 equals 74. So you can put a 2 out front and distribute it once instead of equal to 74, or you can add them twice equal to 74. Another way you could have done this is if you know the whole thing is 74, you could have split 74 in half and then just equal it to one of the pieces. So there's like 3 different ways you can go about it. That's the fun thing about geometry is you can kind of think about it different ways. So we set up 3 problems together. You have ones that you can finish and then you can set up the other ones. Let me know if you need help.